Welcome, learners. In today's Grade 9 Junior School Mathematics lesson, in Kenyan competency-based curriculum, we dive into a real-world data adventure under the strand Data Handling and Probability, specifically the substrand Grouping and Class Intervals. We're focusing on a key skill, determining the appropriate class width for grouping data. By the end of the lesson, the learners should be able to understand the relationship between range, class width, and number of classes when organizing numerical data into groups. Accurately calculate class width using the formula class width equals range divided by these number of classes. Demonstrate precision and attention to detail when creating class intervals to ensure clarity and fairness in data interpretation. Instructions. 1. Choose a number between 1 and 100. Imagine we're collecting data, like asking each classmate to secretly choose their favorite number. This gives us a set of values to work with. 2. Find the largest and smallest numbers. Look through everyone's numbers to identify the biggest one and the smallest one. This helps us understand the full spread of our data. 3. Calculate the range. Subtract the smallest number from the largest. This tells us how wide the numbers are spread out, from the lowest to the highest. Let's go through example 1 from strand 5 on page 225 of Mastering Mathematics together. The masses to the nearest kilogram of 40 learners in Hekima Junior School were recorded as follows. The data is to be grouped into classes. Question 1. Determine the appropriate class width. Question 2. Write down the classes. To answer question 1, carefully examine the given data set to determine the smallest and largest values. In this case, the smallest value identified is 31 kilograms, while the largest value is 59 kilograms. Subtract the smallest value from the largest. 59 minus 31 equals 28. So the range is 28 kilograms. This result means that the learners' masses are spread out over a difference of 28 kilograms. The range gives us a quick understanding of how wide or narrow the data values are, which is useful when deciding how to group the data into intervals for analysis. Deciding on the number of classes. When organizing data into groups, it is important to decide how many classes to use. A good number of classes are usually between 5 and 12. In this case, the range is 28, which is closer to 30. A class interval of 5 will be convenient because it will result into 6 classes. So 28 divided by 5 equals 5.6. Because we cannot have a class width with a decimal in this context, we round 5.6 up to 6. This means each class will cover a width of 5 kilograms. Why this is important? Choosing the right number of classes helps us group the data in a clear and balanced way. Too few classes might hide useful patterns in the data. Too many classes can make the data harder to read and analyze. A class width of 5 kilograms ensures that all values are included and the data is neatly separated into equal parts. We finally conclude that the most appropriate class size is 5. Part 2 of the question requires us to write down the classes. We proceed as follows. In real life, mass isn't always a whole number like 30 kilograms or 35 kilograms. People and objects often have masses such as 30.2 kilograms, 30.8 kilograms, or even 30.75 kilograms. These are known as decimal values, and because there are so many possible values in between the whole numbers, we call this type of data continuous data. When we want to organize continuous data into class intervals, which are just groups or ranges of values, we have to make sure no data falls through the cracks. For example, if someone weighs 29.6 kilograms, and our first class starts at exactly 30 kilograms and ends at 34 kilograms, it's not clear if that weight should go in that group or the next one. To fix that, we adjust the starting point of the first class. Instead of starting at 30 kilograms, we begin at 29.5 kilograms, or use a boundary like 29.5 to 34.5 kilograms. This helps to cover all possible decimal values and prevents overlap or confusion when tallying data. Also, it's important that class intervals are equal in width, so each one captures an equal range of data. For instance, if the first class is 29.5 to 34.5, the next might be 34.5 to 39.5, and so on. This creates a clear and fair way to group and interpret the data. To get the class size, we subtract the lower boundary of a class from its upper boundary of the same class. For instance, 34.5 minus 29.5 equal to 5. Another method for calculating the class size is by finding the difference between successive lower limits or successive upper limits of the classes. For example, if we have the classes 30 to 34 and 35 to 39, the class interval can be calculated as either 35 minus 30 or 39 minus 34. Class width equals 35 minus 30, which equals 5. This means each class interval covers a span of 5 units. In conclusion, the complete set of class intervals is 30 to 34, 35 to 39, 40 to 44, 45 to 49, 50 to 54, and 55 to 59. Together in your groups, try to complete questions 1 to 6 from Mastering Mathematics Grade 9, pages 225 and 226. Today, if this helped you level up in mathematics, be sure to like, share, and subscribe to Jam Teach Tech for more learner-friendly lessons. See you in the next video, where we continue making maths meaningful.